Determine an original function from a composite function. So if we're given, if h of x is the f of g of x graph, we want to know what f of x could be and what g of x could be. So if we're given this h of x graph, this would have come from a g of x equation being substituted into an f of x equation. So I'm seeing a quadratic pattern here because we have x plus 2 here that's squared, and it's x plus 2 here again plus a number. So this would be like saying x squared plus x plus 1. So that's what f of x could have been. And what happened is g of x was substituted in. So in place of the x, an x plus 2 was written, which would mean that the g of x was x plus 2. So x plus 2 was substituted in for x squared to become x plus 2 squared. And x plus 2 was substituted in for the x. And then, of course, the plus 1 remains. Let's look at b. We're going to do the same thing. So again, what could f of x graph have been? Well, I see an x cubed here that could have been plugged in if f of x would have been x plus 1, and then g of x was substituted in and it was x cubed. So if g of x was substituted in for x, it would look the same. Or I could have had f of x graph could have just been a radical, for example, and your g of x graph could have been then x cubed plus 1 substituted in for x. So as long as your f of x and g of x are two separate equations, you cannot just say f of x equals x and g of x equals the square root of x cubed plus 1 again, because then h of x and g of x would be considered the same function. So make sure you don't try and take that shortcut.